Good afternoon. And how are you guys today? It's the last day of the day, session, right? So thanks for coming. I know it's been a long day for you guys. So welcome to our last session. This amazing, I'm glad to be here. It's my first time here in South Africa, or actually African continent. So I'm Ruby Jane Cabagnoth. I'm originally from the Philippines, but I've been living and working in Norway, also Norway, for the past 6 years. Um, so today I'm excited to talk about the 7 deadly cloud sins. So meaning it's a common mistakes that can sabotage our cloud applications and security and performance. So my aim for this session is just basically to leave you with 7 practical tips to secure and optimize your cloud applications. And for those new to the cloud, I think it's a good starting point for, just to get you get to know the cloud, that's what's happening. And for those seasoned cloud developers, okay, think it, think of more it's like a post-its notes in your desktop or in your desk. So yeah. So, okay, let me introduce you to Alex. So Alex, let's say he's a talented developer, just like you guys, I'm sure, who built a shiny new application on Azure. So it was fast, it was feature-rich, and okay, most users love it. But then disaster struck. Okay, so data leaks, security breaches, and slow performance, and a breach system. Why? Because Alex fell into the trap of the 7 deadly sins. But Alex could be just easily just any one of us in our weekdays, and commit this sin. And soon you'll notice that why is it easy to commit one of these sins, or at least. So today we'll follow Alex's journey and uncover these sins and learn from these mistakes to redeem our cloud applications. So this is just about avoiding mistakes. It's about empowering ourselves to build applications that are secure and reliable. So for Alex, first sin, he committed the sloth, or he became a sloth. I don't know how to say it. So, but in the world of cloud development, I would say sloth is just being lazy. It's about neglecting monitoring and logging. So failing to keep a close eye on your application's health. So like think of it like missing your doctor's appointment. Okay, so for a while everything seems fine, and then but problems can go unnoticed, and by ignoring this monitoring, by ignoring monitoring, and then by the time the users started complaining, the damage has been done, and your reputation is that also gone to dust. So, but it's easy to skip monitoring, like what I said, when everything is fine. Okay, so that's why sloth is very dangerous in that sense. So issues like security breaches, performance drops can easily sneak up on you until they're impossible to ignore. Fortunately, there's a way to conquer this sin, and let us stay proactive and avoid this disaster. So, okay, let's see how Azure Monitor can help us avoid this sin. So let's dive into Azure Monitor. So this is a must-have for any cloud developer. So we're looking here, like say your Node.js is on Azure App Service that fetches a secret from a key vault. So without monitoring, we'd miss critical issues like errors or slowdowns, risking downtime and user frustration. So let's see how Azure Monitor helps us stay proactive. So here in our app, we've intentionally broken it by using a invalid secret. And here in our code, we put in an invalid secret value. So basically, the browser shows a secret not found error, proving that the app can't be fetched the secret. So this kind of issue could easily crash your app if especially if left unchecked. So let's see how Azure Monitor catches it. Alright. So here in Application Insights, we use a KQL or query language queries to spot issues. And then here we can see the failed request has been done. And then you can also dig deeper in the failure tab. And then if you can see, there's an error trace here for the secret not found exception. When you click here, so here the error trace, it shows the exact secret not found exception for details like the timestamp and the request path. So basically this helps us pinpoint why it failed. So a wrong secret name and resolve it without guesswork. So why does this matter? So Azure Monitor catches issues like errors and slowdowns early, right? So you can fix them before the users notice. So it is not just about avoiding downtime. So it's about also ensuring that you're meeting the SLA and keeping your app performant. Then we have the next scene, the grid. So over-provisioning permissions. So in the cloud is about, the grid is about taking shortcuts. So like granting your app or team members overly permissive roles, such as, for example, granting them ownership or honors, or contributor access roles to everything, and basically just out of her convenience. So it's quite easy to fall into this trap, especially when we're in a rush or in a deadline. We thought like, okay, we'll fix it later, but when a credential is going to be compromised, so attackers can easily gain control of your application and basically wipe up your entire subscription. So it's tempting to grant broad permission, especially like what I said, if you're under pressure or in a tight deadline, because it's out of convenience. You could just grant permission, but it's deadly. Okay, so one example is one breach in 2022, where a tech giant cost a tech firm like 15 million in recovery in fines. So, for example, in the case of our Alex, so he learned the hard way, and that over-provisioning is leaving the vault, like your vault door open, and giving the thieves your keys to your house. So, how to avoid this sin? Okay, but first, before we do that, if you want to convince your stakeholders or your business suits of the cost of grid, so here's some example. For example, in 2022, like what I said, there's a Twitter breach or X now. So attackers gain access to over-permission employee accounts. So this has far more access than needed. And basically, the fallout was severe. So basically, the user's trust was shattered. And this incident became a textbook case for how over-provisioning permissions can lead to disaster. So the attackers didn't be master hackers. They just simply exploited the excessive access already granted. So that's why grid is so dangerous. It turns a small mistake into a catastrophic breach. But we can avoid this by following the principle of least privilege that we should explore later. So, okay, the key is to follow the principle of least privilege. This means granting only the permissions necessary by user or service to perform the task, no more and no less. So, for example, for Alex, this would have meant giving his service principal reader access instead of the owner, or a specific resource group instead of, for example, contributor. So by scoping their permissions, you basically, even if your credentials gets compromised, at least the damage is contained. Then and you can also use Azure role-based access control or RBAC. So this makes it easy. So you can assign role like, for example, reader or uh, contributor to specific resources or groups, ensuring users have a just enough access. So, and then of course you have to do regularly review roles with your Azure Access Review. So this one, it will at least help maintain the compliance and catch any over provisioning early. So basically, by following these practices, you can prevent Grid's deadly consequences and keeping your cloud environment secure. And then pride is our third sin. So what is this pride in our cloud development story? So I would say being careless with your sensitive data. Okay, so like storing your API keys or your database credentials or passwords directly into your code or your ENV files. Again, it's tempting because it is quick and easy, as always. So, and the consequences, again, are severe. So, if, for example, if your code is exposed, like in your GitHub repo, so attackers can easily steal those credentials, so leading again to data breaches. But why is this a sin of pride? Because I would say it's because we become so I don't know, become so proud of our work, and then we get delulu or delusion into thinking that okay, no one will see our code, or it's fine, I'll remove it later. So one exposed secret can easily compromise our reputations and users' trust. And of course, don't be too proud to think that it will never happen to you, because I'm sure if the news that you've heard of, like, these companies, well-known companies exposing their data, customers' data, they didn't think like, it's gonna happen to them. So let's see how Azure Key Vaults help us avoid this sin by securely managing our secrets. So we have our Node.js app on Azure service, and it is securely displaying my secret value 001, right, which is being fetched from the Azure Key Vault. So it is not hard-coded in our code, so this gets safe from exposure. So in this sense, our intrepid developer, Alex, so he did it right. He didn't commit this sin, at least not this time, or not yet. So here's the magic. We use the default Azure credentials to authenticate with Azure. And then the secret client disconnects our key vault and grabs our demo secret 001. So basically, this keeps our secrets out of our code bases. And here in Azure Key Vault, you can see the demo secret 001 is stored securely as encrypted. Of course, don't click that in your time. It's going to show. I'm just showing it here. The value of my secret 001, you can see. So my secret 00 value in this here, it stays hidden, protecting it from the exposure. Of course, I already disabled this one, so I'm just showing it now. So here in access control, you can see the different role assignments in your app that you can assign to your members. So here you can role assignments that you can choose from depending on your app requirements. And you can add role assignment. So really depends on your app's or your team members' requirement. That's when you can assign a particular assignment or access role. So some post-it reminders for this particular scene. So of course, don't hard code your secrets. So use secret management tools. So inject secrets at runtime. And then control access with management identities in RBAC. So basically, trust no one. And also keep that mind your env or that env files and even private repo, because this one can also get compromised, especially through just pure carelessness. So why use key vaults? So it's best to create separate key vaults for each environment, so to isolate your sensitive data. And then, for example, a production key stores like live API keys, while a development key vault uses test keys. Okay, so now let's move on to your number 4, scene 4, wrath, or ignoring your secure defaults. So in the cloud, wrath is about being reckless. So it's like overriding the secure settings that platforms like Azure or any other cloud providers provide out of the box, such as encryption or network isolation. But bear in mind that these are there for a reason. So whenever you have to override it, or if you have to override it, at least at the very least it's documented. So in this case, Alex was being a bad boy this time. So he committed this sin. So he disabled encryption in his storage account. So just to speed up the deployment. He thought, okay, it's just for testing. And then when a breach exposed the company sensitive data, it cost his company millions of dollars in fines. Again, it's tempting to bypass these defaults, especially if you're under pressure or in a tight deadline. And of course, one oversight can lead to a massive surface attack. Okay. So Alex, our developer, learned the hard way that secure defaults are there for a reason, like what I said. But okay, there's a better way how to avoid this. So let's see that later in a short demo. Some just key takeaways for this sin. Like what I said, trust secure defaults, and then keep your encryption enabled. Isolate your networks, so setting a private endpoint so that only trusted networks can pick in, and basically this will cut off your attackers before they can even get close. And then, like what I said, don't mess with the defaults unless you have to. And then if you have to document them. So at least all of you won't remember, you won't forget it, or your team members will see it. And of course, audit regularly. So tools like Azure Policy can enforce rules and catch slip-ups before they spiral. And of course, this is not just for Azure. Okay, this is applicable to all your cloud providers. This is your first line of defense everywhere. And then there's the gluttony, the misconfigured our scene 5. So misconfigured cloud storage. So gluttony is all about carelessness with your storage. So leaving your buckets publicly accessible or setting improper access controls. So like allowing anyone to read or write in your Azure blobs. So yeah, it's tempting to do this again because public access can feel convenient for testing or sharing. But like what I said, the consequences again are heavy. So attackers can easily just steal your data. So again, leading to leaks, unauthorized access, and hefty compliance fines. So again, I don't know if you've noticed, but most of these things kind of easy to make because we just usually just think, oh, it's going to be temporary, it's going to be no one find it, or it's just going to be for like what I said now. So and then you forget about it, and then of course attackers can easily just attackers are actively scanning our application for open buckets, and then just one slip up for us, can expose us to everything, and then reputations and our company suffer. So okay, some key takeaways for our SIN. So what does misconfigured cloud storage mean? So when you storage, like, for example, your Azure blobs or your AWS S3 or your GCP buckets, is it like being left open to the public or has overly permissive settings? So first, stick to the secure defaults. So cloud providers set storage also to private or for a reason. And don't change it unless necessary or we have to. Second, lock down your access. So you can use role-based access or shared access signatures to ensure that only the right people can get in. So the least privilege principle is your best friend. Just think of it. And then, of course, audit regularly. So tools like you can use tools like Azure Security Center or to spot misconfigurations, and then before they can turn into disasters. And then finally, this might be sound, it's like to be common, but sometimes we forget about it. Train your team. For everyone needs to know the stakes are the stakes are high, and how to configure the storage the right way. So yeah, with these practices, I would say you can steer clear of the gluttony and avoid the sin of gluttony and keeping your data safe. So save time, especially on the building of this Azure. I already run commands for this demo. So here's a mock data in our app containing the word sensitive data. This is, of course, exposed to the world. And here we're using the Azure storage account, which is we created earlier. So we can already run this command to show the result. There's a storage app. And then here we're showing the sensitive data. So here's a public container. As you can see, that the access level is in the blob. So it's allowing anonymous access. This is a classic misconfiguration, leaving sensitive data wide open. But we're going to fix this by lightening security. But for now, this shows how easy it is to accidentally expose data if we're not careful. So now that I've exposed our data, we need to fix the misconfiguration. So in the networking, we have disabled the public network access to disabled. So this blocks all access, ensuring only authorized users can get in. Now, instead of sensitive data, we can get authorization failure. This means autonomous access is blocked. So the confirming a data is protected from unauthorized access. So basically, by disabling public access, we've locked down our storage account from unauthorized, take note, unauthorized users. So this simple step corrects the gluttony of misconfigured storage and aligns with secure defaults, avoiding the sin 4, which is wrath. But now you're here adding a new row assignment, and let's say storage blob reader. So depending on your, it's gonna play this one. So depending on your demand member users, you can also going to assign it. For example, a test user for this level of access, ensuring that only authorized users can read the data. And here you can select your members. Just signed it. For example, in this case, me again. So we can also remove like unnecessary roles like storage blob data contributor or owner share, which had excessive permissions to follow the principle of least privilege. So Yeah, so we've added that. Yeah, it's kind of like what I said. Yeah, I can remove, for example, this contributor role, access role, because it's overly permissive. Okay, we're still getting authorization failure, right? So you're thinking, because basically, uh, we're still making anonymous calls. So user or guests still need to authenticate through their application or through their permissions. So no anonymous access, no necessary permissions. So basically, just secure your storage account for doing this job. Okay, this is the same. Okay, so what's the takeaway? Sorry. Takeaway in a wrath and gluttony. Basically, just secure your cloud. Trust secure defaults. So that's one will be storage private by default. And then configure, secondly, configure your access properly. Like use your RBAC or SAS tokens to ensure that only authorized users can get in. So, and then third, monitor your misconfigurations with tools like using your Azure Security Center to catch your mistakes early. And then protect your data from, you know, with standards like GDPR. And then, yeah. Okay, I have to go fast. Okay, next is number 6, envy. So using outdated dependencies. So envy means clinging to old libraries or the frameworks. So like using log4j.s, which had infamous, you know, exploit that allowed remote code execution. So Alex again made this mistake with an outdated library, thinking, okay, it's worked fine so far. So, okay, but that choice left his app exposed. So an attacker exploited the known, you know, vulnerability, leading to a data breach. But it's like what I said, it's deadly because if you miss security patches, it's performance improvements, and new features. So how to avoid this sin? Okay, do regulate, update regularly. Of course, you have to always use the latest stable versions of your libraries to stay secure. You can also do automate checks with tools like Dependabot, which flags outdated dependencies in your GitHub repos. And then scan for any vulnerabilities using like Snake or every pull request to catch your anything early. And then you can do test updates in a staging environment to ensure compatibility before deploying. So basically, these practices keep your app secure and ready for the future without any to help your app. And then last but not the least is last. So chasing features over security. So last about rushing to release new features without proper security checks. So like skipping your validation for new NPI endpoint. So and we do this usually just because just to ship faster, and then we do hard coding secrets just thinking it was about temporary. Um, yeah, we're running. So before, okay. I'm gonna rush this because we're kind of running out of time, avoiding last week's security CI/CD. So yeah, so basically you integrate security early in your application, so automate scans in PRs. Yeah, but of course you balance speed with safety. And then I'm just gonna do a small demo. So here we have a stack notification saying a hard-coded secret was being detected in our application. So we see the failed pipeline here. So our custom scan found a hard-coded secret in our secret.js, stopping the deployment to keep our up secure. There. So let's say we fix this and remove the hard-coded secret from our code, and then commit and change it. Then we change this so that trigger the file, the pipeline again. So you can see here the pipeline now passes, so no secrets found, so it deploys successfully. And then again we get here we can see the application. And then we get the Slack notification again that it's being deployed successfully. So the Slack alert we got in real time is critical. So it tells us a deployment failed because of a hard-coded secret. So we can fix it immediately. So this kind of alert can help us with this particular sin. So if we had outdated dependencies or tools like Sneak can catch them also. So yeah, so that's it for me. If you have committed any of these sins or you want to share your sins with me, you can talk to me later. So yeah, danke, thank you, and tak salamat. Salamat is my word. Okay.